In this topic, we will be looking at the characteristics of a linear function. Okay, so first of all, let's begin by introducing it. Linear functions. So we can say that linear function is very popular in economics. Okay, so we use in economics to begin with. That's a subject that business students take, and it is also attractive. Linear functions are attractive because it is a simple way, is simple and easy to handle mathematically. And as we all know, mathematics is one of our challenge subjects. Okay, so that's point one. Point two, it has many important applications, and we'll be looking at them as we go along. Okay, linear functions, okay, are those whose graph is a straight line. So once it's a straight line, then that's a linear function. Okay, so we continue. Linear functions now. Linear function can be written as f x equals m x plus c, where we have an independent variable. Okay, and that independent variable is the is the x. Sorry about that. And we have a dependent variable, which is the y. Okay, c in this equation, c is a constant term, or better known as the y-intercept. Okay, so c is a constant term, or as the y-intercept. That's the next way of stating it. It is a value of dependent. So this y-intercept is a value of the dependent variable when x equals 0. Keep that in mind. M now, let me move this a little bit more up. M is the coefficient of the independent variable, which is the x. Okay, M is also known as the slope and gives the rate of change of the dependent variable. Okay, so we have seen that this is the linear function. We know that the m is the gradient or the slope, x is the independent, c, and this side here, which will be the y, is the dependent, c is a constant or the y-intercept. Okay, so now we can state a general equation of the linear function. So let me summarize this in very short terms. The linear function f such that x maps to a x, the x this way, plus c. Okay, this could also be written as f bracket equals a x plus c, or y equals ax plus c. These are just variables that represent the same position. And next way of writing this is that to say such that x, the point xy, such that y equals ax plus c. Okay, where a now, a coefficient of x, c constant term, x independent variable, y is the dependent variable. Okay, so we have identified those things there as for the general equation of the line. Now, because we have identified them, let's see what values do a and c can take. I'm going to write it on the opposite side. The a and c now, we continue on this side. A and c, we can say that they are real numbers, such that a and c are elements of the real number. Okay, so we can conclude that y equals ax plus c is also mx plus c. Okay, so that's what we can conclude at this point. So a, notice here, so a equals m, which is the gradient. Just in case if you are given different letters from what you are usually getting in class, they might change it. Gradient of the straight line or linear function. Okay, c again is the intercept, not a problem. Okay, intercept of the straight line also, let me write this because sometimes you might be given this in this form and you need to be able to read it. Means the set of all ordered pairs x and y such that, that's what that means. Okay, so that is what we have here. Make sure you can go through them and understand it. So remember, this is the linear function where m is the gradient, c is the y intercept, where when x equals 0, with and x is the independent variable, and this fx, which is equals to y, is a dependent variable. That's basically it, and we may have it differently rearranged, but at this point let's just know this basic information and then we proceed to the rest.